All right. Well, thanks for joining us tonight for the fourth in our 2025 Summer Heat Pump webinar series hosted by Walking Mountains. My name is Diego Betts. I am the Residential Energy Programs Coordinator here at Walking Mountains in Avon, Colorado. And I have joining us tonight David Petroy. I'll introduce him in just a few minutes after we go over some housekeeping items and some introduction information. So just so everybody's aware, this webinar is being recorded and it will be available to watch on YouTube within a few days um, after the webinar. I will be sending up a follow-up email to everybody who registered with additional information, the slides from the presentation, as well as a link to the recording on our YouTube page. We will have time for Q&A at the end of the presentation, so please use that Q&A function at the bottom of your screen or the top, wherever it might be. If you have any questions, if you have any technical difficulties, you could also use that Q&A or you can chat us. You should be able to send us a message. If you're unable to chat or use a Q&A, you can also raise your hand and we can allow you to talk. So let's get started here. So tonight is our home weatherization and electrification plan. So creating and implementing an affordable plan for your home electrification journey. This is a new webinar topic for us, so we're excited to get it going. We do have several other webinars that have happened or will be happening. You can see the whole list there. Everything is available to watch on our YouTube page. Recordings are uploaded all to that YouTube playlist. So you should be able to click that link when the slides are sent out. Want to give a big shout out to all of our sponsors for making this webinar possible. We've been able to reach quite a large audience since we started doing these. Our community partners and sponsors include the Beneficial Electrification League of Colorado, Energy Smart Colorado, Holy Cross Energy, Core, Clear, and Tri-State Generation and Transmission. Just want to give a big thank you to all the sponsors for making these webinars possible. Loveelectric.org is a great resource for folks to learn more about electrification. It's a one-stop shop for all of the rebates and incentives in Colorado for both heat pumps and other electrification work. Their website outlines a lot of the benefits of switching from gas, propane, or electric resistance to efficient electric equipment. They provide great explanations and cost estimates for the best heat pump applications, and you can also find a list of qualified installers of heat pumps on their website. They've got great information for contractors, including training and technical resources, and lots of information for homeowners. Search for rebates, find contractors, and learn more about electrification. Energy Smart Colorado is a collaborative nonprofit. They've got 10 nonprofit community partners throughout their service territory. They serve 20 Colorado rural mountain counties, and their collective goal is to make residential and commercial energy efficiency improvements simple and affordable while advancing community-based goals for energy efficiency, electrification, and climate action. So big thank you to Energy Smart Colorado. We, Walking Mountains, are the Energy Smart Colorado partner here in the Eagle River Valley, and they have other partners throughout the state. So definitely check them out if you have more questions about their programming in your area. We have lots of rebate incentives available specifically for heat pump systems. So Core Community Office for Resource Efficiency is the Energy Smart partner in the Roaring Fork Valley. You can see their rebates and incentives listed there. So they have additional incentives for income qualified households, up to $200,000 for commercial multifamily projects, and they also help with new construction. Clear, the clean energy economy for the region, helps Garfield County. They help facilitate Glenwood Springs electric rebates, as well as Xcel Energy rebates for folks in their territory. They have great incentives for income qualified homes and a program called Reenergize for income qualified households in their area. Their rebates and incentives only cover existing buildings. And then here at Walking Mountains, we also offer rebates. You can see the residential and commercial rebates for electrification projects, as well as other various energy efficiency work. We have an income qualified program called Reenergize Eagle County. So if your household qualifies, we would love to get you into that program. Again, we really help serve existing building improvements. So please reach out if you have any questions about our programs, or if you're in clear or Chorus territory, please reach out to them about their program offerings. We're all happy to help. Holy Cross Energy is a big partner of ours, and they have very generous rebates for electrification work. So they rebate both commercial and multifamily buildings as well as residential homes, and they have bigger rebates for income qualified homes. So if you're a Holy Cross Energy member, you can certainly reach out to them for more information about their rebates for any work that you're doing in your home. Holy Cross Energy also has a great new construction program. So anybody building a home or building that is all electric can potentially qualify for rebates for qualifying equipment you see listed there, up to $15,000 for new homes. You just cannot have a gas line installed. So reach out to Holy Cross if you are building a new home in their territory. Holy Cross also has a great new on-bill repayment program for heat pump installations. So if you're looking to upgrade your HVAC system to an efficient heat pump, you can repay some of that cost on your electric bill. They have great terms, no interest, and they stack all of the available incentives for you up front. So they really kind of have a great turnkey solution for helping pay for a new heat pump for your home. Tri-State Generation and Transmission also has a great on-bill repayment program. They've got low interest rates, terms up to 10 years, and there's no credit check. So it's all based on your past utility payment history. So it's not available everywhere right now. Right now, you can participate in the San Luis Valley as part of Gunnison County Electric or Sangre de Cristo Electric, coming soon to White River Rural Electric. And they also offer bonus incentives on top of their standard incentives. If you're going through the on-bill repayment program, you could potentially qualify for those bonus incentives listed there. They'll also help cover the cost of an Energy Smart Colorado home energy assessment. So reach out to them if you're in their territory and have any questions about their new on-bill repayment program. Xcel Energy has great rebates and all-electric new home program. So if you're building to Energy Star Next Gen certification and zero energy ready homes, and you're in Xcel territory, reach out to them about all of the incentives they have available. They can help guide you through the building process, and they'll help you work with their qualified contractors for the program. They also rebate heat pumps for retrofit projects. So if you have an existing system and you're replacing a heat pump, if you're an Xcel Electric and or natural gas customer, you can get great rebates. This year they have time limited incentives with even bigger rebates for cold climate heat pumps. So if you are an Xcel customer, reach out to them or reach out to us and we can help you navigate everything that's available to you for a proper heat pump installation. So I'd like to introduce David Petroy. He's been doing these webinars for us for a while, and he has well over 15 years of experience in a range of renewable energy and sustainable business roles. He was the founder and president of Blue Valley Energy, which is a successful ground source heat pump engineering, design, and installation company out of Boulder. And they've done over 200 installations throughout Colorado. During the early 2000s, David led technical sales of solar and energy power systems for residential and small commercial businesses at RMS Electric. And at Golden Aluminum, which is one of the largest single-site industrial power users in Colorado, David was responsible for leading the adoption and implementation of a facility-wide energy monitoring system as well as upgrades to reduce energy consumption on large industrial production processes. Most recently, he's done work consulting with Excel Energy, helping their customers understand their energy usage. And in 2017, David launched NTS Energy, which is a consulting company focused on providing advanced HVAC and solar solutions to homeowners and small commercial companies while promoting the transition to the new energy economy in Colorado. David holds a master's in geophysics from Washington University in St. Louis, as well as a bachelor's in zoology from SUNY Oswego. So, David, I will hand it over to you. Thanks for having us. And David, sorry, right before you get started, looks like Tom had his hand raised. Tom, sorry I didn't notice you earlier. Did you have a question for us?
No, I asked it in the chat.
Oh, sorry about that. I missed that.
No worries, we're good.
Okay, thanks, Tom. Dave, you're still muted.
All right, folks. Welcome and thanks for attending today. We got about 20 slides today, so it shouldn't be too long of a presentation. We'll have time for discussion and questions. And this is a kind of a higher level overview. We're going to talk about weatherization and just touch on what you should be thinking about with regards to some general stuff and some specifics. We're not going to get into the weeds too much, but an order is going to come out. What should you be thinking about, and how should you prioritize? And then we'll take that and we'll go on to electrification. There's a lot of choices. There's a lot of paths you can go down. How do you think about it? How do you come up with a sensible pathway that fits your timeline, your budget, and your goals? So first, let's go into weatherization. Weatherization is generally the most cost-effective strategy to save energy. And when I say generally, there's different aspects of weatherization. I'm going to look at that. It's the whole house, the whole shell, as you can see here on the right. But really, you're going to maybe attack the attic and the roof, or you're going to look at the walls, or you're going to look at the windows. So various, depending on the strategy, how cost effective it is, depends on the what's the status of your house's construction. You're definitely going to want to implement some kind of weatherization plan before you go with HVAC upgrades, because it'll allow you to have you might get a little bit smaller HVAC system, which will help lower the cost a little bit, and it's going to lower your heating and cooling costs. So depending on what you'll need for weatherization and how important it is, that's a key thing to think about. There's so many local experts. Diego mentioned energy audits. Some of the energy smart organizations offer them for free, greatly discounted. Excel, a lot of utilities, they really want to come out and help you with this, and it's well worth it and not very expensive. And often you need to have these to get rebates, whether it be on weatherization or on upgrading some of your equipment. So let's look at considerations when reviewing the energy audit or evaluation. First, I want to just put us on the same page here. I think one of the things we're going to talk about, weatherization really attacks insulation and air leakage. And insulation is an obvious thing. Air leakage, maybe not so much. This picture shows, you can have air leaks through sort of can lights, various edges of rooms, etc., go up in the attic. And if your attic's not sealed well, it basically gets out of the house. To give you an idea, so the goal is to have less than 3 air changes per hour. Older houses would have 6, 7, 8, 9, 10. There's lots of air coming through. So really trying to control that, because you lose heat and cooling. And we'll talk about when you get a really controlled, tight house, ways to get some fresh air in and a more energy efficient. And then this here is our value is the higher it is, the less heat and cold can go through your walls, your attic. This is like 0 to 55. And this is the resistance or so the lower the number, the more heat that can get lost. So the main point here is that when you're below 20, you start out old days, 11, to have all this loss, 80, the number's 80, and then would go up to about 90. But now we're trying to insulate, especially new homes or when you're redoing it. So you're up in here, you're at R49 to 60, really very low heat flow, essentially really little loss through the walls or the attic. And you're going to have choices with insulation. This is just for reference, quite honestly. Closed cell foam, open foam, cellulose, and fiberglass. And this is how much R value per inch. So, the more expensive stuff you have thinner, it's really tight. You can have quite a few less inches, but there's costs associated with this. And that's just a reference chart. So the biggest energy loss is through the roof. And I call it the attic or the roof. If you have an attic, you're insulating at the bottom of the attic and then trying to seal the house from there. If you don't have an attic, the insulation's at the roof line. So you're going to go, the auditor is going to come in and look, and they might have if you have less than R30, then you're definitely going to want to insulate. And if you're going to want to insulate, you're going to check with the Energy Smart partner and the utility, ensure you're going to meet the rebate requirements. What R value do I need to have? The auditor normally will know that. The other thing, when you start to get bids, you want to ensure that they include air sealing in the attic. So you can go out, they're going to want to go out to the edges of the attic. They're going to want to seal around can lights. You're going to want to make that tight. And the other thing is, if your ducts are in the attic, you can ask them now. The auditors are not going to be, the contractors that do insulation aren't duct experts, but you can ask them to evaluate the duct sealing. Are the joints all together? Are they taped tight? Do they feel like everything's loose? Because if it's all loose and the ducts are leaking, that's not good. And you can ask them, they should be able to do that, or we might get someone in to take care of taping up the ducts and making them good before they pile the insulation. And then here's some options. And this little chart actually shows almost the progression away. Attic insulation used to be down below the joist, and everyone stacked it up. Now, recommendation, you basically stack, and if it's bats, you've got it between, and then you put them the other direction. And so you've stacked way above, so you don't have any heat leaking out by the joists, etc. And you're going to have, bats is a do-it-yourself option. Blown cellulose is really common. It can be do-it-yourself. You can rent the equipment, but if you want to do that, but usually people hire professionals. Spray foam is expensive professional installation. Spray foam is usually normally used in the Now, windows, there's a lot of business in windows. I think the one thing that you need to be careful of is don't be oversold on the overall energy savings from whole house window replacement. They're not, if someone comes in and says, I'm going to replace your windows, I'm going to save tons of energy, tons of cost, generally it might be a little exaggerated. Now, if your windows are single pane and they're very old double pane where the seals are broken and you've got degraded frames, then full replacement of all the windows in your house can result in notable energy savings in those cases. But if your windows are double pane already and the frames are in reasonably good shape, even going, if you full replace them, the energy savings as the primary goal is not really going to be near as beneficial as other opportunities we talk with electrification and other kinds of insulation. So you're going to have someone come in and do an energy audit, and they're going to look at this. But if someone comes in and says, you should replace all your windows, you want to make sure that the energy audit is quantified. Really, how much energy reduction is it going to be? And if they don't have that level of modeling, you might want to hire someone before you spend $20,000, $30,000 on windows to actually do a quick energy model of your house. You can usually get these for a few $100s and really tell you, oh, they're only going to save a few percent, or if it's single pane, they're going to save a lot. Now, another option is if you have pretty good windows, it doesn't hurt to replace the largest windows for comfort and savings. You buy the largest windows, it feels cool. You don't like it, I want better windows. That's usually reasonable. Now, from the table below, which this is just the types of windows, and these are R values. And you can see like the R value for triple pane with 0.25 airspace is, a bit much higher than the double pane with 25, but not a huge amount, but it's much higher than the single pane. So if you replace a double pane with a triple pane of the same airspace, you're going to, for the whole house, typically you might save it 5 to 10%. If you're going to replace a single pane with a triple pane, it's going to get up there more, 12, 18, maybe up to 20. So in that case, you would want to do a model. The next thing we look at is walls and the interior. Now, walls after the attic and the roof are clearly the biggest loss component. But if you're not doing any remodeling or anything, then really the only option is blown-in insulation, where they come and they drill holes in, and they could blow in some cellulose insulation. Now, if you've already got insulation in your walls, like R11, R15, some insulation, you can do this, but it's kind of a difficult, costly thing to do, strategy. So you might want to look at other things until you're going to basically remodel your rooms or something. Now, if you're going to remodel, obviously that's a great time. Make sure the insulation's good. You got a couple options. You can go the bats, or you can the walls. This is where blown-in cellulose is quite good. You can get a lot of R value in between a 2x4 wall. In either case, you're going to want to have thin foam board across them, because you want to have continuous over your 2x4s for leakage, and just, so it creates a continuous barrier. You don't have heat loss across the studs. And check your rebate requirements, especially if you're going to, now a lot of folks, if you're going to finish off your basement, you're going to obviously want to do the walls well. Different strategies there, but you really want to find out. Now, if you're going to replace your siding, that's also an incredible opportunity to really do something. But with the exterior, you got to match the climate zone. So what we do in Colorado is very different than what they do in Georgia, for example, especially with regards to vapor barriers. We're lucky. We're kind of in an area where it's dry, so we don't have as much moisture issues, but still you want to do it right. You want to have the vapor barrier in the right spot. You're going to want to have foam board underneath the siding. A lot of manufacturers now make some siding with some levels of insulation in them, which really helps. So you basically make sure it's going to meet the requirements for local energy smart rebates and the codes. And even if you do not extensive, let's say you just decide I'm going to do one foam board with an R4, that's going to make a big difference, because your wall might only be R11. Old wall inside. So you're going to go, or R15. So you're going to suddenly go from down here to up here. So it's going to be on this part of the curve where a little insulation makes a difference. So, at a high level, you just get your energy audit. You want them to walk you through the priorities of where they think you're going to get the most bang for your buck. Now, I would be a little bit, it's very difficult. You make a lot of assumptions about energy prices, et cetera. So it's not so easy when you say, well, what exactly is the cost savings or payback? That can give you relative savings, but I would just take that, I wouldn't count on, oh, it's going to be a, payback at 3 years or 5 years. Just saying most of these kinds of things, you're going to get a payback in probably the 5 to 10 year range. But you're going to have a much better house. And with the weatherization, you have the extra thing, you save money on it. When insulating, be sure that you got air sealing. So whether it's the attic or the walls, whatever component you're doing, make sure you've got air sealing, and make sure they meet the rebate requirements. So not complicated, but pretty straightforward strategy. So the electrification is, you really need to think about what is your goals. Think hard about the priorities. Now, recognize that we're talking a time frame for major appliances of 15 to 25 years. So when you upgrade your heating system or your hot water heat or um, your range or your dryer, that's the timeline you're going to be in. So you're saying, well, I want to electrify. My question is, why do you? So there's various reasons. One is, there's neighborhood air pollution, GHG emissions. The other is, the big picture. Do you want to help the energy system move kind of more toward electric and transform off of gasoline? Are you concerned about your indoor air quality? Electrification isn't the only answer to this, and I'll talk about why it's important to think about air quality. And the other thing you might say, well, I think I can save a lot of money. I think people have told me I can save a bunch of money. Certainly, I can do. That's really, sadly, it's rarely true that you're going to do one of these things and save a lot of money, and every year. I can say that in most cases you're going to save some money, and it's going to vary more years than not. You're going to save money, but it's going to be up and down. But you're not going to introduce higher operating costs for your house. But they're not going to be half. They're not going to be 25%. It might be 10%. Fluctuate. And there's two pathways to achieve all of these goals. One pathway is eliminate all natural gas use from my home. I want to be fully electric. The other way is, and each of these components is to greatly reduce the natural gas use in your home, 75% plus reduction, which will still, over the next 15 to 25 years, achieve these goals and make a huge difference. So looking at this color ball on the right, I'm going to divide, there's really the big NG users and the little guys. So the big ones are space heating and water heating. And those are, and actually cooling is not really, these are the two big ones. Space heating ties in with cooling because with heat pumps, they do both. And cooling is a big one, even though it's not NG, it's a big energy use. It's high in the summer, it strains the grid. So the more we can do, the better. So space heating, if you reduce, so these are the big ones, 30% cooling, 12%. And I added in the car because even though it's not natural gas, the cars use gas and they're a huge component to all of your goals. So there's reasons you want to think about your automobile when you're thinking about all this. And then water heating. And then the little guys are over here. Cooking and dryers, 1.3%, 3.2%. So these are the little guys. So even if you get, a full electrification, and I realize here I put cooling, which is already electric by nature, so I need to change that. But these guys, the car, the water heating, big amounts of reduction. These are kind of in the noise. They're a little amount. Doesn't mean you don't want to do them, but just realize if you're going to do these things, you really are doing them for mostly other reasons. They're not huge energy use. So how do you prioritize your changes? Well, first thing is you want to find your appliances that need replaced, ones that are old. But if they're less than 12 years old, I wouldn't consider replacing them because they still have a lot of life left in them. There was a lot of energy and materials put in those appliances. And if you throw them out at half their life, now the water heater, 12 years, they say replace it 12 years. Water heaters, typically last 15 years or so. But you're getting up there. But basically, you don't want to throw stuff out that's working well. You put your money for now into other stuff. There's other things you can do. What are those? Well, one is you can weatherize. And high priority. So if you get your audit, the person comes in and says, the walls are good, the windows are pretty good, the attic really could use insulation. There you go. If they say, well, the attic's good, windows are good, walls are kind of low, well, all right. Do you need new siding? Are you going to remodel some of the rooms? Then you think about it because however much you lower your home's energy use overall, you'll save money. The other thing then you look at is your vehicle. You say, well, vehicles are replaced 5 to 10 years, 120,000 miles. You know, they are a big deal in terms of pollution, et cetera. So for your primary vehicle, the one you'll go on road trips, go over the country, you can go with a plug-in hybrid. Those are very good transition vehicle. You get 30 miles, and I'll explain how you can get a lot more all around town. And then, or you can go with electric if you are confident in terms of the way you travel, et cetera. You are going to be able to do your charging and do well. For your secondary vehicle, the round town one, electric or plug-in hybrid, both work. If your vehicle is not ready for replacement, then you can go with a solar system. There's really very little solar systems. We need them. We need them on our homes. We need them on the grid. The one thing, don't overdo it. In the past, everyone's been like, you got to offset 100% of your energy. Well, what happens during the months, there's sometimes too much solar. California has this issue where at times they've got way too much solar being produced and they've got to dump it off the grid. So don't oversize. If the guy said you got to do offset 100%, that's really not necessarily true. And there's no need to spend all your budget on it. You can go with 50%. That's pretty nice. 60%. And then you can consider your future needs. You can say, well, tell me an offset of 50%, 60%. Give me a couple quotes. And then I'm going to add a little bit for EV charging in our heat pump. So you can size it that way and get something that fits within your budget. A lot of these new homes, I notice they're putting on various developments. They're putting on like 5 kW, which is great. Now I would even consider adding a battery to that, because what that does is it gives you more flexibility. You can, for when you can charge your vehicle, when you're producing extra, you can save it to charge your vehicle. So in a way, I consider that kind of like gas station, electric gas station on the roof. So I'm trying to give you let's give an idea of, what's this cost? What's the money situation? So from top to bottom, on this bright slide, I've got sort of the things. If you've got needed, all your appliances are great. They're all new and stuff. So we start with the things that you could do in here. And you got hybrid cars, you got solar, and actually I'm going to add in, before we send this out, weatherization. And so these things, this is the initial cost over like a gas car, for example. And this is, not over nothing. This is like what the cost would be. So here you got, that's kind of initial cost, but then you've got various level 2 chargers. You've got rebates and credits. The federal credit for solar is still good, 30%. Colorado has nice car rebates. The federal car rebates are very narrow now. They only a couple models, so I didn't really include them. So the cost after your final cost, just is to give you ballpark ideas. So you're looking at 8 to 10,000 for cars that make a big impact, and you're looking around for 5 kW, something that might give a lot of the houses half their juice, 16,000, near 17,000. And your reduction in your natural gas use is going to be 50 to 75% on the hybrid, because driving around town all the time, doesn't use any gas. And then the percent of family energy use, these are about 1/3. So they're, it's big. And then you go to the ones. So next step, oh, my heating system is old. My air conditioner is old. I need to replace it. That's the heat pump world. Right now, this is kind of the sweet spot, the heat pump world. You're going to spend 3 to 10,000 more over furnace and AC, depending on, there's various levels of heat pumps and strategies. I got the whole webinar on that. But anyway, you've got a lot of rebates, and they range. Excel's is quite benefit. If you're in Excel territory, you get an extra $6,000 this year. So take advantage of it. Lots of rebates. So the cost over sort of furnace and AC can be nothing to several thousand more, depending on what level system you get and your local rebates. And it can reduce your gas use, depending if you do a dual fuel or all electric, 60 to 100%. So this is one of the big guys. And then the water heater, you've got heat pump water heaters, you got electric water heaters. Electric's not much more than gas. And that's basically how I explain. That's basically putting in the electric line. Heat pumps can be more, but you've got some nice rebates. So this is a much smaller scale, 1 to 4,000, but 14%. And then the little ones, heat pump water, electric dryers, heat pump dryers, stoves, their cost above just the standard gas is not near as much with rebates. Now we're sort of the 2000 and less, but really not much impact. So I'm going to go through each of these and make a few comments for your thinking. So electric PV versus gas. I'm telling you, there's so much misleading information online. It's just unbelievable. I mean, I'm not sure why. We've been evolving in technology. These are new technologies, they've evolved, but there's just sort of this fermented war between this in a lot of ways online. So basically, don't pay attention to a lot of, there's about maintenance more, maintenance left, maintenance more, maintenance less. I'll tell you, in the worst case, maintenance is equal. In a lot of ways, it's less. I have a plug-in hybrid. I don't have to do anything to that car. It's still got a gas. I mean, the oil change rather than, I drive, still got to change the oil, but, driving 2/3 on my electric. So oil changes are a lot less electric. So maintenance, fuel cost is another one. And you're going to see people say, gosh, it costs me so much more to drive with this or that. And that's all has to do with what's the pricing of a home electricity and gas. And in Colorado, the worst case is break even for electric. And in most cases, you actually save a fair amount, especially if you got solar on your. When people online are complaining about it's because they're in California, they got high electricity prices and maybe lower gasoline prices. Another just quick bite about plug-in hybrids. You usually get about 30 miles or so, a lot of them. But the cool thing about those is you plug them in, they charge up really fast. So actually, in a given day, charge it up quick. You can get not 30 miles, but 60 miles. So quite nice. Heat pumps, boy, that's a great sweet spot. Really, there's no reason for anyone to put an AC in. Heat pump-based systems, there's either full electric, which has a heat pump with an indoor unit and an electric strip in there to supplement it when it gets super cold, or you got a heat pump with a gas furnace. Basically, it's an air handler for the heat pump. The heat pump's the primary guy. The furnace works when it's cold. So just little different strategies. This picture on the right kind of shows it. This is outdoor temperature, 0 to 70, and this is the percent of annual heating. Up in Eagle, and notice 1/3 of the heating is above 35. Half of it's between 35 and 15 outdoor, and only about 1/5 is less than 15. And so if you have these strategies, you've got, in one case with the electric, got heat pump and a combo, and then the electric way down here for a little bit. And the furnace one, you can design it. You could do the same, like only the furnace having a little bit, or you can really, because gas costs relative to E-strip is low, you can have a heat pump and then furnace. In this case, you can actually move this line around depending on the cost of fuel. So there's so many benefits, heating and cooling, 65% less energy use, reduces your heating bill 50% or more versus propane or electric. Get natural gas. It's basically kind of on par in Colorado. And any given year, depending on the price of NG, can be 10%. The heat pump can be 10% less. It can be a little more. Basically on par. It really reduces the local air pollution and GHG emissions reductions. Water heating. So if you want to go electrify, there's two options. There's a heat pump water heater, and you can think of it, what it is think of your utility room. Your house heats, the utility room stays, maybe 70, maybe in the 60s. It's got heat. Actually, you don't even know that it's in there because you're not in your utility room. And so what the heat pump water heater does is it sucks the heat from there, pushes it into the hot water, and the room might cool down 10 degrees or 10 or 15 degrees. You don't notice it because the house is heating, and eventually sort of seeps in that room, heats up again. So you can kind of think of it as a little extra heat in that room, and think of the water heater as sipping the heat out of it and using it in a better way, using it to heat the water. But you need a big enough room. And if it's not big enough, you can compensate. You can put vents in the walls to help pull heat from other rooms, or you can duct it. And then it uses 60% less energy than electric water heaters. So even though those are both electric, they're not sort of, they're kind of apples to oranges. The cost to operate a heat pump water heater is similar to natural gas. Now, if you can't fit one of these in, and by the way, next week we have a whole webinar. Electric, low cost to install. If that's your only choice, it's good. You can get it in. It's going to cost more to operate than this guy here. You're not going to get quite as much GHG reduction. You get air pollution, no air pollution, local air pollution, but as the grid, especially Holy Cross and Excel, get greener and greener, eventually, this is going to have dramatic GHG reductions. A couple more things. We got dryers. There's something called heat pump dryers. And what they do is they extract moisture from the clothing, and you can read about it in here how it does it. But basically, there's energy in the extracting moisture conversion, which is pretty nice. It's a nice little clever way to do things. Uses 25 to 50% less energy than full electric. There's no venting required. However, this is really a technology just coming on the scene in a way. In the US, there's limited options. They're really smaller size units for like 2 people. And they have longer run times, 15 to 30 minutes more. They're not quite as quick as drying the clothes. So as long as you're aware of those, like I said, this thing isn't a huge contributor to energy savings, but I think in the future, probably you'll see these going into new homes as a regular thing in the next 5 years or so. I mean, electric dryers are a perfectly great option. They meet all your benefits, and they'll still over time save a lot of GHG. So, electric dryer is obviously a good strategy. Cooking stoves, induction stoves are becoming the rage. A lot of people wanted a kind of a cooking experience that's alternative to NG. Realize the induction and electric stoves, they use the same ranges. Like the ovens are the same technology, so you're not really saving that. It's really a bit less energy in the cooktop part of it. So they're very small in the grand scheme. Remember, like 1.5% energy uses there. But it's a different cooking experience. It's closer to NG, but it's different. There's no hot stoves top. I think people like that. And one thing you can do if you're like, well, I don't, they're notably more money. They're notably more money if we go back to my chart. But you can have this experience. Like you can buy a single burner one, or I think it's like $100, $150, and you can actually try it and use it and see if you like it. The big question often is, when do I upgrade my electric service? If I have 100 amp, it's not quite enough. So when you get an improvement that forces you to upgrade, I think that's really a strategy. So you're like, all right, I'm going to do my heating system. Can I get it in? The electrician says, yeah, you can do it. All right, then I'm going to buy an EV in a couple of years. The EV comes. Can I get it in? No. Then at that point, you kind of have to do that. So why is that? Because what's happening, smart electric panels are coming out. And they're very good, but the utilities are like testing them, sort of giving their approval and make sure that their utility customers gain the benefit of. So you really need to find out from utility, what have they tested? What do they think is going to work for you as their customer? And have they approved it? The one exception to this kind of what I'm calling a rule is when you install a solar system, you should consider the upgrade then, because basically often with the solar, you have to get a new panel. The panel's too old. It doesn't work right with all the safety, et cetera. So that's a time where you might want to consider that. It can be costly, but some utilities have rebates. And when they do it with the solar, this cost is probably less because, well, it is less because they're out there and they're already doing all this stuff. So all the labor costs go sort of are greatly reduced. Um, and give electric capacity priority to big users. That's one of the reasons, electric dry, like you say, well, my dryer's going, that's 40 amps. Use the gas dryer, some gas works great. That's a circuit you could say, all right, I'm going to save it for something big. The same might be for your water heater. So you might want to consider that. So indoor air quality. So a lot of people, they're reading things and saying indoor air quality is bad, it's dangerous. I have to get rid of every gas. Well, your energy assessment, your auditor will come out and evaluate your appliances. And it's not the nature of those appliances that's dangerous or hazardous. It's they're not done right. They're not vented right. If it's not up to standard, it should be repaired. I mean, is the venting good? The kitchen stove hood, they're supposed to have, good CFM and it's supposed to be outside vented. So a lot of these indoor air quality studies are in places where none of this stuff's done right. And so you've got that. So you want to get it up to speed. If it's a new thing, you don't throw it away and say, I got electric because it's not vented correctly. The other thing is overall indoor air quality. After you weatherize an air seal, if your house is kind of leaky and getting fresh air in all the time, that's not an issue. But if you build a new house these days, their air changes, they're sealed. It's like being in a tight bread box. So you need to have something called an energy recovery ventilation. And that's a nice fresh air system. What it does, a little picture here, brings in air. It works in conjunction with your furnace or your air handler. If it's an all electric heat pump system, the air comes from the outdoors and it goes through this little box. A little portion, about 10% of your already warmed air comes out and it exchanges the heat and the energy, the moisture. So what happens is air that would be coming in cold, like say, it basically you can think of it as adding about 30 degrees to the air. So rather than the winter bringing in 0, you're going to bring in 40, 45 and mixes in with the air and it warms up. And the same thing in the summer, you've cooled your air, you're not wasting the cooling. So it's a really good system. It can be retrofit to existing HVAC systems. It can be put up by itself. Like this is a good thing to do in basements. If you finished off your basement, it's really tight. You want some fresh air in there. It's a very nice little system. So I think with electrification, understand what you're thinking about, really understand your goals, think about it, prioritize what needs replaced. If nothing needs replaced. Is there something in the weatherization audit that's really low? Okay, do that. Or do you need a new car? Or always solar, a great option. And if your budget's limited, spend your money on your big guys. Spend it on these. I get it. The stoves and the dryers, are nice. They're different level, but really think about that. And weatherization of high priority stuff before HVAC upgrade. And that's it. Thank you. And I think we have time for questions.
Yeah, thanks so much, Dave. It's a great informative presentation. If there are any questions, please feel free to put them in the Q&A, or you could also raise your hand. We can allow you to talk if there are any questions. Give it a moment here. Let them come in. Dave, I have a question. Could you maybe talk a little bit more about, if somebody is looking to install a heat pump and upgrade their HVAC system, how does, weatherizing their home, if they have deficient insulation, how is that beneficial to, um, to a new heat pump installation?
Well, there's two ways. It's beneficial to the heat pump when you're purchasing specifically. So let's take an example. Let's say that your attic, your attic is losing. It's responsible in your case, someone's case, 30% of the energy loss. It's got very poor insulation. You can drop that down. You can cut that in half. So that might end up where you might size a heat pump for a 4-ton heating load before you did that insulation. And it might help you to put in a slightly smaller heat pump. Usually that's kind of stuff's going to go a half a ton. And so it might save you about $1,000 on the heat pump sizing. So it helps you to get a little smaller system, a little. And then the second thing is it will help you, in your heating and cooling costs every year, because the percent that you lowered your heating or cooling requirements for your house by insulating the attic always is going to be a benefit, no matter putting in a new heat pump system, having a heat pump system already there, a young system. So that's how weatherization benefits you in two ways.
Great, thank you. And we have any other questions from folks? Feel free to raise your hand if you'd like. I can allow you to talk.
All right. Well,
Okay. Well, we're not seeing anything come through, so thanks again, Dave, for your great presentation tonight. And
thanks,
thank you everybody
everyone.
for joining us. Again, this recording will be available within a few days. I'll send it out to everybody who registered, as well as all the slides and some additional information. So
All right. Thank you, everyone. Have a good evening. Thanks,
thanks,
Diego.
everybody. Take care.
Bye.